Now let's learn how to integrate a product of two functions. We know that the derivative of the product uv with respect to x is given by u dv dx plus v du dx. If we integrate all through, that means uv is equal to the integral of u dv plus the integral of v du, which means the integral of u dv is the same as uv minus the integral of v du. This formula is used for integrating a product of two functions, and it is called integration by parts. Let's take an example. Evaluate the integral of x sine x. It's important to choose the appropriate function as u. And what we do is choose a function that has a derivative which is simpler than itself as u. That's important. U must be a function whose derivative is simpler than itself. If you don't choose appropriately, then you will not be able to evaluate the integral. So here I'm choosing x as u, and the rest of the function, the rest of the product will be dv. So that means my integral will be u, which is x, uv. V is the integral of sine x. If dv is sine x dx, then v will be the integral of sine x. So you just integrate dv to get v, which is minus cos x minus the integral of v, which is minus cos x dx. Integral of v du, which is minus cos x dx. If u is x, that means du dx is 1, and that means du is dx when you cross multiply. So that's why we have dx as du, and we proceed. That means minus x cos x plus the integral of cos x, which is minus x cos x plus the integral of cos x is sine x, and then you have a constant. So that's it. Let's take another one. Evaluate the integral of x ln x. What do we choose as u? Here, u is ln x and dv is x dx, because the derivative of ln x is simpler than ln x, but that of u is ln x. U is ln x and dv will be x dx. Here we know that ln x is not a derivative, so we cannot say dv is ln x dx. So it's better to choose u as ln x and x dx as dv. So that means the integral is uv, which is ln x multiplied by v. If dv is x dx, then v is x squared over 2 minus the integral of v, which is x squared over 2 v du. Du will be, du is 1 over x dx. If u is ln x, then that means du dx is 1 over x, which means du is 1 over x dx, just by cross multiplication. So we can proceed. This means x squared over 2 ln x minus 1 over 2 multiplied by the integral of x dx. X squared divided by x is x. So this means x squared over 2 ln x minus 1 over 2 times the integral of x is x squared over 2 plus c. And this means x squared over 2 ln x minus x squared over 4 plus c. And that's all. Let's take another one. Evaluate the integral x e raised to power minus x. What is u here? U is x, and dv is e raised to power minus x dx. Now we can integrate. That will be uv, which is x multiplied by v will be the integral of e raised to power minus x, which is e raised to power, which is minus e raised to power minus x, minus the integral of v, which is minus e raised to power minus x du. Du is dx, and this is, and that means minus x e raised to power minus x plus the integral of e raised to power minus x dx, and that is minus x e raised to power minus x plus minus e raised to power minus x plus c, which is minus x e raised to power minus x minus e raised to power minus x plus c. So let's take another one. Evaluate the integral x cubed e raised to power minus x. As usual, u is x cubed, and dv is, the whole of the rest is dv, which is e raised to power minus x dx. That means uv, which is x cubed, v, which is minus e raised to power minus x, that's the integral of e raised to power minus x, minus the integral of v, which is minus e raised to power minus x v du times 3x squared dx. How did I get that? If u is x cubed, du dx is 3x squared, and that means du is equal to 3x squared dx. That's just by cross multiplication simply. Now we continue. We proceed. That means minus x cubed e raised to power minus x plus, I can bring out this 3 to make it plus 3 times x squared e raised to power minus x dx. 3 times the integral of x squared e raised to power minus x dx. And that's, so we can see that this is another product. X squared e raised to power minus x is another product. So we also integrate it by the integration by parts formula. So u is x squared, and e raised to power minus x dx will be dv. And I integrate as usual. That means minus x cubed e raised to power minus x plus 3 times u, which is x squared multiplied by v, which is the integral of e raised to power minus x. That's e raised to power minus x minus the integral of v, which is minus e raised to power minus x du, which is 2x dx. And that means minus x cubed e raised to power minus x plus 3 into minus x squared. You have to be careful with the expansion, plus 2 multiplied by the integral of x e raised to power minus x. Now, there we go again. This is another product of two functions. This is u and this is dv. So I do that again by the method of integration by parts. That's minus x cubed e raised to power minus x plus 3. Okay. Before I integrate by parts, let me open this square bracket. That will be minus 3x squared e raised to power minus x plus 6 multiplied by the integral of x e raised to power minus x dx. So here, this is u, and the other of this is dv. Which means minus x cubed e raised to power minus x minus 3x squared e raised to power minus x plus 6 times u, which is x, v, which is minus e raised to power minus x, minus the integral v, which is minus e raised to power minus x dx, du, which is dx. And that becomes minus x cubed e raised to power minus x minus 3x squared e raised to power minus x plus, no, okay, let me write it that way first of all, plus 6 times minus x e raised to power minus x plus the integral of e raised to power minus x. And that means minus x cubed e raised to power minus x minus 3x squared e raised to power minus x minus, that's minus 6x e raised to power minus x plus 6 times the integral of e raised to power minus x, which is minus e raised to power minus x plus c. And that's the final answer. And the final answer is minus x cubed e raised to power minus x minus 3x squared e raised to power minus x minus 6x e raised to power minus x minus 6 e raised to power minus x plus c. Minus 6 e raised to power minus x plus c. And that's the final answer. So it's as simple as that. What's important is that you choose the right function as u, and you are very careful in your evaluation and expansions. U must be a function that has a derivative which is simpler than itself. And you say it's very easy. So that's going to be it. Please subscribe to this channel and hit the like button for notifications as soon as another video is, to get a notification as soon as another video is uploaded. Thank you very much, and God bless.